In this video, we're going to see how to perform a code review in GitHub. So first of all, why code review? It's a good learning experience for all parties involved. You learn when you're doing a code review because you get to look at somebody else's code. You also learn when a code review is performed on your code because you get somebody else's perspective on how you could have written this and maybe some improvements you could make. So this naturally improves our quality because we're having a second set of eyes to look at technical debt and consider how we can reduce that technical debt. Now, when do we review? We often will review when we finish a pull request in GitHub. And I'll tell you that's a little different from how we're going to do it in this class, but I want to show you what it looks like nonetheless. So I've gone to a pull request that I've already merged. And when I choose Files Changed, you notice that I can click a little plus here, and then I can add a comment, and after that comment I can choose Start a Review. So this is the traditional way that a review happens, where we're going through and we're just making some suggestions in line where both the code reviewer and the person being reviewed can see those comments right in the code. Our process is going to be just a little bit different because we're reviewing each other's projects at the end of a sprint, and we don't know how those other projects might have used branches. Plus, when we're doing our code review, what we don't want to have is just a description of what could change, but the code reviewer should actually make those changes in code in a separate branch and then create a pull request and then describe the rationale for creating those changes. So, create a branch, propose our changes, and then changes should be implemented in code and not just described. So what are the steps? First of all, let's take a look at the assignment. And towards the bottom, you'll see a list of projects and the team members for those projects and the code reviewers that I've assigned to those projects. Now, I've gone through and I've evenly distributed code reviewers throughout all of our projects to ensure that all the projects get a fair review and they have basically 3 to 4 different reviewers on it instead of maybe 16 people piling on one project and then 1 or 2 people on the others. So take a look down there, make sure that you are assigned to review a project and make sure that you're also on the roster for a group project. I created this roster from the design documents. So that's where I came up with these names. As long as you submitted a design document and your group had more than 1 member, you're on here. If you submitted a design document for a group with 0 members, I rejected that immediately because the group project must be done in a group format, ideally with 3 members. So check your name. Also check for your own group to make sure that the Scrum board and the GitHub link are up to date. If not, let me know and I will go to update them. Now, what I'd like you to do is look at the project that you're assigned to. Contact the group members and just let them know your GitHub ID. Now, if you're the group's DevOps member, or in other words, the person who's managing the GitHub repo, you should go out and add each of these individuals to your project as a collaborator because that gives them the ability to create a branch, which is something that we're going to need. So everyone, verify you're in a group. DevOps, add the code reviewers to your project. To do that, we'll simply go to the project and then we'll click on Settings. It may prompt to confirm your password at this point. Now, manage access and invite a collaborator. And here you enter the GitHub ID of the person who wants to be a collaborator. I can't add myself because I'm already C, but you can see it auto-completes. As I start typing, it's pulling up individuals who have these letters in their GitHub username. So DevOps, add those. If you haven't heard from all your code reviewers, go back to that list in Canopy and feel free to reach out. Notice there's an inbox feature over here. That's where you can go and you can drop an email to your classmates. So that will get us set up. And then what do we do next? Well, okay, let's say that I'm reviewing this project, My Plant Diary Queue. And this is the project we've been working with all term. So here again, I've done all the work on it. Kind of silly for me to review it. But nonetheless, we'll pretend that I am. So the first thing is get the clone URL. So I click on Clone or Download and I click this little copy link right here. Okay, now Android Studio, File, New Project from Version Control. So I open Android Studio, choose File, New, Project from Version Control, and then Get. And now we'll go ahead and paste in that path. I'm going to go ahead and leave the directory where it is. It's essentially going to reclone this into a brand new Git repository and create a brand new project, even though I already have it on my hard drive. So I'll go ahead and choose Clone. That will take just a moment. Now it says, okay, I've cloned that Git repo and I'm ready to open the project. Do you want me to open it in a new window? I'll say, sure, go ahead, open in a new window. We'll give that just a few moments. It's going to build right now. Building will take a moment, but make sure that the project does compile and run. If the project doesn't compile or run, reach out to the group and just ask for instructions to get it to compile and run. So you want to build this a little bit into your schedule because it might take a moment for the group to get back with you, so you don't want to save this part for the last minute. Now, the reason why we want to make sure it compiles is that you are going to create a branch with your changes and you're going to push your changes up to our version control system. You should never push something broken up to version control, with a possible exception of test-driven design unit tests. Everything should build. That's a prerequisite even to getting our CI/CD pipeline to work. So make sure that the project compiles, ask for help if not. Once you've confirmed the project compiles, create a new branch. And this is key, because remember a branch, which we've used all semester long, a branch is like a snapshot at a point in time of another branch in the repository, usually the master branch. And it's a sandbox where we can make any changes we want, and those changes will not impact master until or unless the changes are merged. And that's why we want to do our code review in a separate branch, so that you can have a sandbox and you can make whatever recommendations you want, and you can have the freedom to do that, and then you'll get a bit of feedback from me and from others, and that will be part of the learning process. So create the branch and then look for some best practices. So a lot of times I get a comment where people say, gosh, I really didn't have any ideas here. I didn't know what to do. Well, if that's the case, just go out and do a search for best practices, or I was looking at visibility modifiers here, but you can still look at best practices and come up with a few good sources. A couple pages I came up with, there's a conventions page here and a few other pages. So use this as a script to help you think about what to change as part of your code review. Part of the reason I looked up visibility modifiers is I've been a little bit lazy, I'll say, so far this semester. I have been not defining a visibility modifier, and so by default it's public, which means that our declarations are visible anywhere. When I look at it, really internal might be a better possibility. So when I look at these standards, I realize, there are some improvements that I could make. So we want to actually go in and make those changes as part of the code review. We don't just want to say, hey, remember to change this visibility modifier. Actually make the change. So with all of this talking, I'm going to bet that our project has finished building, and sure enough it has. It says build successful, so that's great news. So now let's create a new branch. In Android Studio, where it says Git Master, we can choose New Branch. And again, you see I've been doing that all along here in our learning modules, so hopefully this isn't new to you. As a matter of fact, I've cloned this project to a brand new location, but you can see all the branches that I've created so far came with it. Nonetheless, let's go ahead and create a new branch. Your new branch name should be your 6+2, in other words, your Bearcat ID. So Jones BR for me. And then underscore, and then code review 1, just like so. Something like that, so I can identify who did the code review and that it is a code review. Definitely you want to leave checkout branch ticked. Look down here at the lower right where you see Git Master. When this is all finished, it should update to our code review branch, and you see now we have that code review branch. Let's take a look at plant service, and we see there's this fun fetch plants. Maybe I should make that internal fun fetch plants, give that a different visibility modifier. Now I have a hunch there are a few other places where I can do that as well. So if I take a look at live data, it looks like those, okay, good. I have a lot of things that are done well there. Now I do see here on the location live data that the companion object is the last thing in the file. Should it be there? Well, luckily the Kotlin reference coding conventions tell us the order that they recommend. So property declarations and initializer blocks at the top, secondary constructors after that, then method declarations, then companion objects at the bottom. So it looks like this companion object is in a pretty good place. The longer the class, the less likely that is to be the case. You see here under main fragment, you see I have a companion object that's defined at the top. Well, Kotlin recommends we put those all the way at the bottom, so I can just do a cut, and I can paste that down towards the bottom. So you see at this point I've made two distinct changes to my application. I'll take a quick look through here. Our access modifiers generally look good on these. I see most of them are private. I could probably do a little bit of housekeeping up here, just kind of bring everything a little bit closer together. Now I look at my constants, I see they're all uppercase with underscores separating them, and I look at my properties and I see they're lower camel case. And I go back to the coding conventions, I see that a constant should be uppercase underscore separated names, so we look good there. I see that mutable data should be camel case with a lowercase first letter, so we look good there. Those things check out just fine. I can keep looking around here. Okay, fun get location live data. I could probably make this one internal. Now that won't count as a separate unique change because I essentially did the same change on plant service, but nonetheless it's nice to be consistent. So far at this point I've made two changes. One is adding the internal modifier 2 times, the other is putting that companion object in the correct place. I can keep looking around for unique changes. Some good things to look for is when a user is using a magic number and not using a constant. It's better to make a constant out of that, but specifically a constant that describes the purpose of that variable. So make sure that it's descriptive. Camera permission request code, it's very obvious what that's for. Now remember, you're in your own branch here, you can do whatever you want. So one thing I absolutely do not want to see is this. You should change this to a more descriptive name. I mean, suggesting something in a comment in code, because you see, this is clutter. Adding this here is discussion, which is cluttering up the code base. Instead of saying what the user should do, go ahead and do it. Propose it in code. Now, when you have the pull request, there will be plenty of time to have discussion and rationale there. Save that for the pull request where you have the time value of the source code that you're looking at. Because you see, if you try to have a conversation in code, that's going to live on beyond just this pull request. Now, don't get me wrong, documentation is great, but true documentation that says what this class is doing or what a function's doing, not a conversation going back and forth telling somebody they should have done something a different way. If you're looking for ideas or you feel stumped, just go back to those best practices documents or find some of your own by searching online. And then when you do the commit and the push and the pull request, then you can annotate your changes with that best practice documentation. So let me show you how to do that. Now I'm happy with my changes, and this is part of the assignment I'd like you to do. Right-click and say commit directory, and then just say my code review suggestions. And then we'll do a commit and push, and commit and push, push again, and then we go back to our repository, and we see that this branch was pushed Jones BR code review. At this point, I can compare and do pull request. And as the code reviewer, I'd like you to do this as well. Now, right here is where you can put a bit of rationale about your changes. You can kind of do an overview of the project that you've reviewed. So you can say description of the project. This is a plant diary keeper. I'm not going to be very verbose here. I just want to show you a few comments. The code review itself tells you what to put. What I learned from this code review. Okay, what I learned from the code review, I'd like you to describe what you learned by looking at somebody else's code. Don't describe the code review process itself like I learned to use Git. Say things like, I learned how to use live data to consume GPS, something like that. I learned about the internal visibility modifier when I did my research for this code review. I learned how to create constants instead of use magic numbers. So something like this. Don't just say, I learned how to make better code. Be very precise on what you learned. And then describe the program as well. Was it available on time? So on and so forth. Put some description in here. You can do it here, or you can do it after you create the pull request. So I go ahead, create pull request, and now you can go through and you can add even more here. Again, take a look at the description. I say exactly what I'd like to see in your analysis. An analysis of the program. Was it available on time? Was it documented, commented? Does it compile? And then rationale behind your changes, along with 3 specific technical concepts that you learned. So put all of this in the commentary section. Now, go to Files Changed, And you see you can add a bit of description here. So I click the little plus, and this is where I can give a reference. So I can say updated the visibility modifiers per the suggestions here. And then I can grab this URL that has the documentation, and boom, like so. And then just choose add single comment. Don't worry about start a review. That's different. That's when you're reviewing a pull request, which is what we talked about earlier. Just go ahead and add single comment. The handy thing is I can see this, and the project team can see this, and so you can have a really good conversation back and forth about whether or not you want to keep these changes. At the end of this video, I'll show an example from a prior semester where a student did a code review on another group, and then that other group went back and forth with the student and had a discussion, and I chimed in as well. This is where learning really happens, because it gives you an opportunity to try to speak a language that you think you might know or you might not know. When I worked in Mexico, I would read Spanish books on the way to Mexico and try to memorize vocabulary. But it wasn't until I actually started speaking Spanish that I realized I had memorized the words, but when I was speaking them in the wrong order. And the way I realized that is I started speaking, and some of my friends who were both Spanish and English speakers corrected me and told me what I was doing wrong. This is where you get that opportunity to practice what you've learned and get feedback from the group that did it, as well as get feedback from me. And that feedback can be, boy, you're smart, you know a lot of words, but you're putting them in the wrong order. Let me help you to put them in the right order. So this is how we have that conversation. And this will take us just about into the home stretch of our conversation on how to do the pull request. So you've committed 3 distinct changes, and that means not repeating changes. Commit and push your changes. In GitHub, create the pull request. Don't merge it, just create the pull request. Add the code review discussion and rationale to the pull request as I just showed you. Add the discussion of changes in the files changed section. You notice here, files changed section, and you can see in red everything that was removed, and in green everything that was added. You can see here, for example, that I simply moved the companion object from the top down towards the bottom. So here I might add, and as a matter of fact, one handy thing is you see you can actually click and drag for this plus. You can drag an entire section, and you can say moved companion object down as specified, or let's say to the bottom, as specified here. Once again, grab our reference and paste. Now references will definitely help because it will help you to make sure that you're doing things the right way. It also might help you to learn something new. So sometimes I see code reviews where it's just one person's personal preference versus another. But if you have the actual link or something of that nature, or even say just as discussed in the lecture videos in class, that helps to really show that it's not just opinion, but you're doing a fact-based change. Finally, all you need to submit for the code review is the URL on Canvas. So we come right back here, and this is what I want you to submit. I see the word pull in there, which is good. If you don't submit a pull request, a few things will happen. First of all, if you don't submit anything, I won't know to grade your project, and you won't get a grade. Sometimes I've had students just submit a link to the repository without a specific pull request. If you didn't do the pull request, that's definitely a point deduction. I've also occasionally had students who just send me a link to a branch without actually sending me a link to the pull request or without creating a pull request. That would result in a point deduction. As a code reviewer, that's all you need to do. Now what I will do is I will take a look at each of these code reviews and each of the pull requests, and I will go through and make a recommendation. I might say, I recommend merging these changes, and my recommendation is based on one question. Did this code review increase or decrease technical debt? If it decreased technical debt, then I'll generally recommend merging. If it increased technical debt or it's hard to tell, it kind of didn't move the needle either way, I typically will not recommend merging. But let's say, okay, I recommend merging these changes. That's what I do as part of the grading process. So as the code reviewer, you're all done now. Now, as the group that's receiving these changes, you have the option to go ahead and merge them in as you would merge any other branch, which I'm going to go ahead and do now. Now, part of our grade sheet is that you need to merge in at least 3 code review branches this semester. It can be either from the first code review or the second sprint code review, but either way you need to come up with 3. And that's a good motivation to have a lot of stuff to be reviewed, because the more stuff you have to be reviewed, the higher quality the review will be. So, I mentioned several things about the code reviews and how these can be used as a good learning opportunity. What I wanted to show you now is from a previous semester, a group of students who really leveraged this code review to learn from each other and have a discussion with each other. Here's a look at a really good code review I had in a recent semester. This student did a description of the program out on the merge request, on the pull request, which is what should happen. So basically kind of describe the changes that you made, make an analysis of the program. Was the program available for you? Did it compile? What are some concepts that you learned from the review? Now you see what we can do with this pull request is we can take a look at the files that were changed and we can add comments. What I really like about this code review here is notice that the discussion is not in the source code itself. But take a look down here. The code reviewer made a change and then explained the change using one of these comments in line. And to make a comment, you simply look for the plus, click, and there you go. You can write a comment. I'll cancel this one out, but that's how you kind of start this discussion. So don't be tempted to add comments in code to describe your intention. That's not what that's for. Instead, use this discussion here. Note that the student started here, and this is what I really like. One of the team members of the project getting reviewed added a comment back, and then I commented again. And you see this pattern repeats over and over again several times. So what happened is it went from a code review to a very healthy discussion where all parties were learning, and I was able to go in and add a bit of contribution myself. So that's where code reviews can be really helpful. We want to put that discussion here in the pull request, and then we also want to have a pull request that we create where we describe what we did in the code review.